Alright, silly people, here's the situation. This time we're going to be doing some Fourier transforms on some waveforms of musical instruments, particularly a waveform of a piano and a trumpet. Uh, those waveforms are on the online resources. Just go download the piano.txt file and the trumpet.txt file from there, because we're going to be doing discrete Fourier transforms on those to figure out what notes they're playing. So always just import numpy as np, especially now because we're going to be using the numpy fast Fourier transform package to do this. Also import matplotlib.pyplot as plt, so we can plot the waveforms with the Fourier coefficients on the right next to them. So here, let's just create a bunch of figures. It's going to be a plt.subplots object 2 by 2. That just means there's going to be 4 plots arranged in a square. Also load in the data, so piano is going to be equal to numpy load text, just creating a variable called piano for the piano data, and also create a trumpet variable which represents the trumpet data, right? So here we can go ahead and just plot those. So plt plot the piano on the top left corner of the subplot, so it'll do ax 0, 0 dot plot that, and then on the second row, first column, also plot the trumpet waveform, so plot trumpet. Then we can do the Fourier transforms. Going to create a variable called cpiano for those Fourier coefficients, equal to numpy fft.rfft is what you want to use for this, running piano through it. Same thing for the trumpet data. Just run it through numpy fft rfft. And then we can plot the Fourier coefficients on the same subplot. So it'll be first row, second column dot plot the absolute value of the piano data, and I even just want the first 1,000 Fourier coefficients, because the other ones, they will end up not mattering. Also, second row, second column, plot the trumpet Fourier coefficients. Also, only the first 1,000 of those. Right, so you run that. Oh, I'm plotting the wrong thing. Plot C piano and C trumpet for those. My bad. But yeah, you can see the piano waveform on the left with its Fourier coefficients plotted on the right, then the trumpet waveform with the trumpet coefficients on the right. You can see that the trumpet data has a very prominent peak at around 900 something for K, and also the piano data has a peak around 250 for K. How do we translate into musical notes is what the next part of the problem is. So the problem statement does say that the waveforms are recorded at 44,100 samples per second. So I'm going to record that in a value called f. And then also let's do a loop to figure out where these maximum values exactly are. So let's do a loop, or first let's create a variable called k piano, which is going to represent the maximum k value, and then k trumpet, which is going to represent the maximum k value for the trumpet data. You run a for loop for k in range. You definitely want to start at 10 because the piano data has this weird peak around 0. You can just ignore that. The real peak data is going to be here. So you start at 10 and you go to 1,000 because we're not going any further than that. And you check if the absolute value of the C piano indexed at K is greater than the absolute value of C piano indexed at K piano. If that's the case, then you set K piano equal to K. Also, if same thing, if the absolute value of the trumpet data indexed at K is greater than the absolute value of the trumpet data indexed at K trumpet, then you make the new value for K trumpet equal to K. And now that will allow us to print out where the actual exact peaks are. So for the piano, it says it's about 245, and the trumpet saying it's around 964. So we can use those. Gonna need the length of the data as well. So let me define a variable n to be the length of the input data for piano. And down here after the loop, we can have it print out, or have it calculate anyway, the piano frequency, which is always just K times the sample rate, so K piano times the sample rate over however many samples there are. Same thing for the trumpet frequency. You take your K value, you multiply it by the sample rate, and you divide it by how many samples there are. And once you have those, you can print out the frequencies here, and we get something like 108 hertz for the piano and 425 hertz for the trumpet. And so that corresponds to the piano playing a low G sharp, and then the trumpet playing a high G sharp. And they're both pretty sharp values for those. So somewhere in between G sharp and A for sure. But they're both playing the same note, just on different octaves. All right.